In today's video, we are going to discuss about solution of triangles. Sometimes it is also called as the properties of triangles. So suppose we got a triangle here, triangle ABC. Now, if we draw a circle joining all the three vertices, we get a circle like this, and it is a radius r of the circle. This radius is called circumradius. And the side opposite to A is denoted by small a, and the side opposite to vertex B is denoted by small b, and the side opposite to vertex C is denoted by small c. So A, B, C are vertices of the triangle, and A, small b and small c are nothing but length of sides BC, AC and AB respectively. Relation between ABC and small abc is given by some rules. What are these rules? One is the sine rule, another is cosine rule, and the third one is a projection formula. You can also call as a projection rule. So we are having here is the three rules. What are the three rules? One is the sine rule, cosine rule, projection formula or projection rule. So relation between A, B, C, that is the vertices of triangle, and small ABC, that is the length of sides of triangle, given by sine rule, cosine rule and projection rule. Sine rule is given by this relationship. What is the relation? According to the sine rule, let us call this as a, call it as a C, and this length is equal to B. So the sine rule formula is A upon sine A equals to B upon sine B equals to C upon sine C equals to 2R. In general, the 2R can be denoted by K. Therefore, sine rule, also popularly known as A upon sine A equals to B upon sine B equals to C upon sine C equals to K, where K equals to 2R. Now, second one is a cosine rule. In cosine rule, we got the relationship between A, B, C and the angles in terms of cos theta. So that is A square. First of all, you write down like this, A square. I am giving you a trick to remember cosine formula. So write down A square here, B square and C square. Now the first formula, A square equals to, when you return the A square, then the remaining side of B square plus C square. Then after that, you write down minus 2BC and cos A, which on simplification gives cos A equals to B square plus C square minus A square upon twice BC. So according to the cosine rule, the formula for cos A is equals to B square plus C square minus A square upon twice BC. Similarly, if you wish to find out B square, then what are the other two sides? Other two sides are C and A. So you write down A square here, then write down C square here, then write down minus twice AC, then you write down cos B. Implies, we can also write it like this, cos B equals to A square plus C square minus B square upon twice AC. Similarly, if you wish to find out C square, then C square can be written as A square plus B square minus twice AB cos C implies cos C equals to a square plus b square minus c square upon twice ab. So these are the three formulae, and these three rules are called cosine rule. The projection rule gives the relationship between cos function and the sides of the triangle. Suppose you want to get the formula for A, then A equals to, when you write down A, what are the two missing sides? B and C. So write down B here and write down C. So when you write the B here, what is the other end? Other end is a C, so write down the cos C. Then here is a C, so you write down the cos B. Similarly, B equals to, when you want to get the B, what are the other two sides? A and C. So A into cos C and C into cos A. Similarly, if you wish to find out C, then the remaining sides are B and A. So when you write down the B here, write down cos A, here is the A, then write down the cos B. So these three formulae are called as projection rule. Now let us practice some problems based upon sine rule, cosine rule and projection rules. Example 1. If in triangle ABC, if angle A equals to 45 degrees, angle B equals to 60 degrees, then find the ratio of sides of triangle. Solution. Two angles are given, the third angle is not given, and we know that angle A plus angle B plus angle C equals to 180 degrees. So we have the angle A 45 degree, angle B 60 degree, and we don't know angle C equals to 180 degrees. So angle C equals to 180 minus 105. Therefore, angle C equals to 75 degrees. Now by sine rule, A upon sine A equals to B upon sine B equals to C upon sine C equals to K. Therefore, A upon sine A is nothing but 45 degrees. B upon sine B nothing but 60 degrees. C upon sine C, that is a sine 75 degrees equals to K. We need to find out the ratio of A is to B is to C equals to how much. From tables of trigonometry, we know the sine 45 value. Sine 45 equals to 1 upon root 2 and sine 60 value root 3 upon 2. But we don't know sine 75 value. So how to find out sine 75 value? I will calculate the value of sine 75 separately and come back here. To find sine 75, 75 can be written in terms of two standard angles, that is 30 plus 45. After that, applying the formula sine of A plus B equals to sine A dot cos B plus cos A dot sine B. By using this formula, we can easily find out the value of sine 75. Therefore, sine 30 plus 45 equals to sine 30 dot cos 45 plus cos 30 dot sine 45 value. Sine 30 1 upon 2, cos 45 1 upon root 2, cos 30 root 3 upon 2, and sine 75 sine 45 1 upon root 2. So this becomes 1 upon 2 root 2 plus root 3 upon 2 root 2, that is equals to root 3 plus 1 upon 2 root 2. So sine 75 equals to root 3 plus 1 upon 2 root 2. Now we have the values of sine 45 1 upon root 2, sine 60 root 3 upon 2, and sine 75 equals to root 3 plus 1 upon 2 root 2. What you do now, you will put the values in place of sine 45, sine 60 and sine 75, keeping ABC as it is. So A upon sine 45 nothing but 1 upon root 2 equals to b upon sine 60, that is root 3 upon 2 equals to c sine 75, that is root 3 plus 1 upon 2 root 2. Since we have to find the ratio of the sides and this is equals to k according to the sine rule, so implies a equals to k multiplied by 1 upon root 2 and b equals to k multiplied by root 3 upon 2 and c equals to root 3 plus 1 k into root 3 plus 1 upon 2 root 2. Since we need to find the ratio of A, B, C, so A is to B is to C equals to K upon root 2 is to root 3 K upon 2 is to K into root 3 plus 1 upon 2 root 2. Now equalizing all denominators. We have A is to B is to C equals to K upon root 2 is to root 3 K upon 2 is to K into root 3 plus 1 upon 2 root 2. We need to find ratio, so there should be some cancellation. For that, equalizing the denominators. For equalizing the denominators, we have to write down the missing term. For that, we need to see the largest term, that is the 2 root 2. Here is the only 2. In the middle term, only 2 is there. Root 2 is absent. So multiplying and dividing by root 2 here, and in the first term 2 is absent, so multiplying and dividing by 2. After that, cancelling common terms. So what are the common terms? K, 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 and 2 root 2, 2 root 2, 2 root 2. These are the common terms. After the cancellation of the common terms, what is left? That we'll write now. Therefore, A is to B is to C equivalent to, here is a 2, here is a root 3 multiplied by root 2, here is a root 3 plus 1. So A is to B is to C equals to 2 root 6 is to root 3 plus 1. This is required ratio of the sides of the given triangle. Example 2, the angles in triangle ABC are in AP and the ratio of sides B and C equals to root 3 is to 1. Find angle A, angle B and angle C. Solution. Here the three angles are in AP, that is angle A, angle B and angle C are in AP. So implies whenever the three numbers are in AP, the 2 into middle term, that is a 2 into angle B equals to addition of first term plus last term. So that is the property of AP. So this is the equation number 1, and we also know that the addition of three angles equals to 180 degrees implies angle A plus angle C equals to 180 minus angle B. Therefore, call it as equation 2. Now putting 2 in 1, so we get 2 into angle B equals to 180 minus angle B implies 3 into angle B equals to 180 degrees. Therefore, angle B equals to 60 degrees. This is the step number 1 is over. Now the step number 2, we need to find out the values of angle A, angle B and angle C. So B is to C equals to root 3 is to 1. So we have here the sine rule. A upon sine A equals to B upon sine B equals to C upon sine C equals to K. So implies B upon C equals to sine B upon sine C. Here B is to C equals to root 3 is to 1 implies B upon C equals to root 3 upon 1 implies root 3 upon 1 and angle B nothing but 60 degrees. So write out the 60 degree here, and here is a sine C. So implies sine C equals to sine 60 upon root 3 implies sine C equals to root 3 upon 2 into 1 upon root 3. Root 3 get cancelled. We get 1 upon 2. Therefore, sine C equals to 1 upon 2 implies C equals to sine inverse of 1 upon 2 equals to 30 degrees. So we have the angle B value 60 degrees and angle C value, that is 30 degrees. Now what is left? Angle A is left. How to find out angle A? We know that angle A plus angle B plus angle C equals to 180 degree. Angle B value 60 degree. So put here, and angle C value 30 degree. Put here, equals to 180 degrees. So angle A equals to 180 minus 90. Therefore angle A equals to 90 degree. So we wanted to find angle A, angle B and angle C. So what is the result? Angle A 90 degrees and angle B equals to 60 degrees and angle C equals to 30 degrees. This is required solution. Example 3. In a triangle ABC, prove that sine of B minus C upon 2 equals to B minus C upon A into cos A by 2. Solution. To find the solution, what we do? We will rearrange the things like sine of B minus C upon 2. Keep it as it is. And from the right side, cos A by 2 will bring to the left side. That is cos A by 2. What is left now? B minus C upon A. Now we'll take RHS and prove LHS. So taking RHS. What is RHS? B minus C upon A. We'll apply the sine rule here. From sine rule, we get B equals to K sine B, C equals to K sine C, and A equals to K sine A. So these are the three values putting in the RHS, that is B minus C upon A. So call it as a 1, call it as a 2. So putting 2 in 1, we get here, in place of B, you can write down K sine B. In place of C, you can write K sine C. And in place of A, you can write K sine A. This is equals to K common, we get sine B minus sine C. In denominator, we get K sine A. K get cancelled. And in now numerator, we apply this formula. Sine C minus sine D equals to 2 cos C plus D by 2 into sine of C minus D by 2. So in numerator, I am going to apply this formula. So we get here 2 cos B plus C upon 2 into sine of B minus C upon 2. In denominator, we apply the formula because sine theta equals to 2 sine theta by 2 dot cos theta by 2. Therefore, sine A equals to 2 sine A by 2 dot cos A by 2. So in place of sine A, we can write 2 sine of A by 2 dot cos of A by 2. These 2 and 2 get cancelled. And in place of B plus C by 2, you can write 180 minus A by 2 equals to 90 minus A by 2. Why I kept B plus C equals to 180 minus A? Because A plus B plus C equals to 180. Therefore, B plus C equals to 180 minus A. This was the reason. Therefore, here in place of cos B plus C by 2, I can write cos of minus A by 2 into sine of b minus c by 2 divided by sine of a by 2 dot cos of a by 2. Now cos of 90 minus a by 2 nothing but sine of a by 2. So sine of b minus c upon 2 divided by sine of a by 2 dot of cos of a by 2. That is equals to sine of b minus c upon 2 divided by cos of a by 2. That is equals to LHS. Therefore, LHS equals to RHS proved. Example third, in a triangle ABC, prove that 2 into a sine square c upon 2 plus c into sine square a upon 2 equals to a plus c minus b. To solve this question, first I am going to use LHS, and the second is I am going to use the formula. What is the formula? Formula is cos square theta equals to 1 plus cos 2 theta upon 2 and sin square theta equals to 1 minus cos 2 theta upon 2. So I am going to use this formula, sin square theta equals to 1 minus cos 2 theta upon 2. So sin square theta, what is the formula? Sin square theta equals to 1 minus cos 2 theta upon 2. Therefore, sin square c upon 2 becomes 1 minus cos 2 into c by 2 upon 2. 2 get cancelled. We get 1 minus cos c upon 2. Similarly, sin square a upon 2 equals to 1 minus cos a upon 2. So, in place of sin square c by 2, I am going to write 1 minus cos c upon 2, and in place of sin square a upon 2, I am going to write 1 minus cos a upon 2. So here 1 minus cos c upon 2, and in place of sin square a by 2, 1 minus cos a upon 2. After that, let us simplify further and open the bracket here. So a minus a cos c upon 2 plus c minus c cos a upon 2. This can be written as 2 into a minus a cos c plus c minus c cos a whole upon 2. These 2 and 2 get cancelled, which is equals to a minus a cos c plus c minus c cos a. So this is equals to a plus c minus a cos c minus c cos a. Taking minus common, so a cos c plus c cos a. By projection rule, a cos c plus c cos a equals to b. Therefore, LHS equals to a plus c minus b, which is nothing but RHS. Therefore, LHS equals to RHS. Proved. Example 4. In a triangle ABC, prove that sine of b minus c into sine of b plus c equals to b square minus c square upon 4r square, where r is the circumradius of the triangle ABC. Taking LHS, sine of b minus c can be expanded sin b cos c minus cos b into sin c. Here sin b cos c plus cos b, which on simplification we get sin square b into cos square c minus cos square b into sin square c. Now keeping sin square b as it is, this cos square c can be written as 1 minus sin square c minus, and this cos square b can be written as 1 minus sin square b into sin square c. Opening the brackets, sin square b minus sin square b dot sin square c minus sin square c plus sin square b dot sin square c. This and this cut down. This is equals to sin square b minus sin square c. By using sine rule, we get the sin b equals to b upon 2r and sin c equals to c upon 2r. So putting these values here, sin b nothing but b upon 2r and sin c, that is nothing but c upon 2r. This is outcome of sine rule. So this is equals to b square upon 4r square minus c square upon 4r square, which is equals to b square minus c square upon 4r square equals to RHS. Therefore LHS equals to RHS. Proved. Example 5. In a triangle ABC, prove that a cube into sine of b minus c and so on equals to 0. It is a cyclic function. Taking LHS. Now this a cube can be written as a square into a, b cube can be written as b square into b, and c cube can be written as c square into c. Now by using sine rule, a equals to k sine a, b equals to k sine b, and c equals to k sine c. In place of a, we are writing k sine a, and in place of b, we are going to write k sine b, and in place of c, I am going to write k sine c. Now in a triangle ABC, the addition of three angles equals to 180 degrees and a equals to 180 minus of b plus c. So in the place of a, I am going to write 180 minus b plus c, and in place of b, I am going to write 180 minus of a plus c, and in place of c, I am going to write 180 minus of a plus b. So in place of sine a, I have written sine of 180 minus b plus c. In place of sine b, I have written sine of 180 minus c plus a, and in place of sine c, we have written sine of 180 minus a plus b. Now let us recall formula from basic trigonometry, that is sine 180 minus theta equals to sine theta. Therefore we get a square into k, and sine of 180 minus b plus c can be written as sine of b plus c multiplied by sine of b minus c. Similarly, b square into k, here sine of c plus a into sine of c minus a, because sine of 180 minus c plus a becomes sine of c plus a. Now the third term, in similar way, sine of 180 minus a plus b, that is equals to sine of a plus b into sine of a minus b. Now there are three formulae. Sine of b plus c into sine of b minus c equals to b square minus c square upon k square. Similarly, sine of c plus a into sine of c minus a equals to c square minus a square upon k square. And the third one, sine of a plus b into sine of a minus b equals to a square minus b square upon k square. Therefore a square k as it is, In the first bracket we can write b square minus c square upon k square plus b square k, and in the second bracket we can write c square minus a square upon k square plus c square into k. Sorry, here I have forgotten to write k. Then here it becomes a square minus b square upon k square. This k cancelled, k, what is left? 1 upon k, and a square into b square minus c square plus b square into c square minus a square plus c square into a square minus b square. 1 upon k, opening all the brackets, a square b square minus a square c square plus b square c square minus a square b square plus c square a square minus b square c square. Let us see what are the cancellation. A square b square cancelled, a square c square cancelled, and b square c square and b square c square is cancelled. So 1 upon k into 0 equals to 0 equals to RHS. Therefore, LHS equals to RHS, proved. Example 6. In a triangle ABC, if a square, b square, c square are in AP, then prove that CotA, CotB and cotC are in AP. This problem can be solved by using these three relationships, 1, 2 and 3. That is, a square equals to b square plus c square minus 2bc cos A, and b square equals to, when there is a b square, you write down other two, that is a c square plus a square, then minus, then here is a c, here is a a, so 2ca, and the third angle, that is a cos B. Similarly, when you are writing the c square formula, then write down the other two, that is a square plus b square, then minus symbol, then minus twice a and b, and the third angle other than a and b, the third angle is a cos C. Therefore, c square equals to a square plus b square minus 2ab cos C. These three formulae I am going to use here to solve this question. And what is given? Given is a square, b square and c square are in AP. So implies 2b square equals to a square plus c square. After that, going to put the value of b square, a square and c square. So we kept the values of b square, a square and c square. Now we'll open the bracket. So we get 2a square plus 2c square minus 4ac cos B. And here b square plus c square minus 2bc cos A, and here is a b square plus a square minus 2ab cos C. Here we can write 2 into a square plus c square minus 4ac cos B. Here we can write 2b square plus c square plus a square minus 2 common, and here bc cos A plus AB cos C. 2 a square plus c square can be written as a b square because it is a given condition of AP. So 2b square minus 4ac cos B equals to 2b square, and c square plus a square is also equals to 2b square minus twice, here is a bracket as it is, so this becomes 4b square minus 4ac cos B equals to 4b square minus 2bc cos A plus AB cos C. B square get cancel both side. So we get minus 4 AC cos B equals to minus 2 BC cos A plus AB cos C. Both side minus get cancelled, applying sine rule. That is A equals to K sine A, B equals to K sine B, and C equals to K sine C. This is nothing but sine rule. Therefore, we get here 4A, that is K sine A, into C, that is K sine C, into cos B equals to 2. Here 2 ones are 2 twos are cut down. Then B nothing but K sine B, C nothing but K sine C, and cos A, and A nothing but K sine A, B nothing but K sine B, and cos C. So we get 2K square sine A sine C cos B equals to K square sine B sine C cos A plus sine A sine B cos C. From RHS, we now take sine B common. K square cancel both sides. So 2 sine A sine C cos B. Now we have taken sine B common. So what is left? Sine C cos A plus sine A cos C. So now bringing this sine B to the left side. So we get 2 sine A sine C cos B upon sine B. This sine B I brought here. Equals to sine C cos A plus sine A cos C. 2 sine A sine C cos B upon sine B nothing but cot B equals to sine C cos A sine A cos C. Now dividing both side by sine A sine C. So we get 2 cot B into sine A sine C upon sine A sine C equals to sine C cos A plus sine A cos C upon sine A sine C. This is sine A cancelled here, sine C cancelled. We get here the cot B, and here sine C cos A upon sine A sine C plus sine A cos C upon sine A sine C. Cancelling similar terms, sine C get cancelled here, and sine A get cancelled. Implies 2 CotB equals to here cos A upon sine A plus cos C upon sin C implies 2 cot B equals to cot A plus cot C implies cot A, cot B and cot C are in AP. Hence proved. Example 7. In a triangle ABC, prove that cos A upon A plus cos B upon B plus cos C upon C equals to A square plus B square plus C square upon twice ABC. To solve this problem, I am going to use this formula. So cos A equals to B square plus C square minus A square upon twice BC and so on, cos B and cos C formula. How to remember this formula? You see, while finding out the cos A, there is a minus A square. While finding out the cos B, there is a minus B square. And while finding the cos C, minus C square. And when there is a cos A, the B square and C square are positive. Cos B, A square and C square are positive. And while getting cos C, A square and B square are positive. And upon twice B and C, upon twice AC and twice AB. When there is a C, there is a upon AB. The C is missing. When there is a cos B, upon B is missing. That is a twice AC. It's a funny logic, but okay. While finding out the cos A, there is a is missing. A term is missing, and we got upon twice BC. So to solve this question, I am going to use this formula. Here I kept cos A value. Here I kept cos B value. Here I kept the cos C value. This becomes B square plus C square minus A square upon twice ABC plus A square plus C square minus B square upon twice ABC plus A square plus B square minus C square upon twice ABC, which is equals to B square plus C square minus A square plus A square plus C square minus B square plus A square plus B square minus C square upon twice ABC. So this and this get cancelled. A square x square get cancelled. C square and C square get cancelled. What is left? A square plus B square plus C square upon twice ABC. That is equals to RHS. LHS equals to RHS verified. Therefore, LHS equals to RHS proved. Example 8. In a triangle ABC, prove that A squared sin 2B plus B squared sin 2A equals to twice AB sin C. Here I am going to use sine rule formula, that is A equals to K sin A, B equals to K sin B and C equals to K sin C, and I am going to select LHS. So I am having LHS equals to A square sin 2B plus B square sin 2A. In place of A, I am going to write K sin A. So K sin A whole square sin 2B, and in place of B, K sin B whole square and sin 2A. So this is equals to K square sin square A and sin 2 theta can be written as 2 sin theta into cos theta. Therefore, sin 2B can be written as 2 sin B into cos B plus K square sin square B, and in place of sin 2A we can write 2 sin A into cos A. After that, whatever the common possible, first of all we will remove the brackets, then whatever the common possible we'll take it out. So here I am opening all the brackets sin square A 2 written here and the sine B into cos B plus 2 here k square sin square B sin A into cos A. After that, I can take the common. What are the common? 2k square common, then sin A common, then sin B common. What is not common? Written in the bracket, that is sin A cos B and cos A sin B. So 2k square sin A sin B, and this becomes sin A cos B cos A sin B becomes sin of A plus B. And we know that in a triangle A plus B plus C equals to 180 degrees, then A plus B equals to 180 minus C. So this becomes 2k square sin A sin B sin of 180 minus C. This is equals to 2k square sin A sin B sin C. Now what you have to prove? You have to prove 2AB sin C. For that, we are going to apply the formula. What is the formula? A upon sin A equals to K implies sin A equals to A upon K. So here 2k square, in place of sin A you can write A upon K. Similarly, in place of sin B you can write B upon K into sin C. Here is a k square, here k cut down, that is equals to twice AB sin C, that is nothing but RHS. Therefore LHS equals to RHS proved. In a triangle ABC, prove that summation of A into sin of B minus C equals to 0. Solution: summation of A into sin of B minus C. This can be written as A into sin of B minus C plus B into sin of C minus A plus C into sin of A minus B. Now by sine rule, A can be written as k sin A into sin B minus C plus k into sin B into sin of C minus A plus k into sin C into sin of A minus B. K is common. In place of A, we can write 180 minus of B plus C into sin B minus C plus, we already taken K as a common. In the second bracket, we get sin of, in place of B, we can write 180 minus of A plus C into sin of C minus A plus sin C. In place of C, we can write 180 minus of A plus B into sin of A minus B. So this is equals to K into sin of 180 minus theta. Sin of 180 minus theta equals to sin theta. Therefore, sin of 180 minus of B plus C is nothing but sin of B plus C multiplied by sin of B minus C plus second bracket sin of C plus A into sin of C minus A. Similarly, the third bracket sin of A plus B into sin of A minus B. Now the formula sine of x plus y into sine of x minus y equals to sine square x minus sine square y. Therefore, here is a k as it is. This becomes sine square b minus sine square c, and second bracket becomes sine square c minus sine square a. The third bracket becomes sine square a minus sine square b. Now let us see what is the cancellation. Minus sine square c plus sine square c get cancelled, minus sine square a plus sine square a get cancelled, and sine square b minus sine square b get cancelled. So that is equals to k into 0 equals to RHS. Therefore, LHS equals to RHS. Proved. Example number 10. In a triangle ABC, prove that b plus c into cos A plus c plus a into cos B plus a plus b into cos C equals to a plus b plus c. To solve this question, I am going to use projection rule here. According to projection rule, a equals to c cos B plus b cos C, and b equals to a cos C plus c cos A, and c equals to a cos B plus b cos A. And to get these terms, what I am going to do, I am first opening all the brackets and make the pairs. So open the brackets, that is a b LHS equals to b cos A plus c cos A plus c cos B plus a cos B plus a cos C plus b cos C. Now making the pairs, so we are going to write here first b cos C, this I have written here, then c cos B, this one. After that, a cos C here plus c cos A, then b cos A and a cos B. By projection rule, this becomes A, this becomes B, this becomes C. Therefore, LHS equals to A plus B plus C equals to RHS. Therefore, LHS equals to RHS. Proved. So friends, how did you find solution of triangles? It's quite easy, provided you are knowing the formulae thoroughly. I request you to start solving the problems from your textbook. If you find difficulty while solving, please contact me on my email address provided in the description box. How did you find this video? Please write down your comments in the comment box. Meet you again with another topic. Till then, wish you good luck. All the best.